Good morning, students. Today we'll be going to study the chapter 2, acid, bases and salt. Hmm? So first let us study what is an acid. Hmm? So acid, about acid, first we can study the properties of acid. So first one, they are sour in taste. The acids are sour in taste. So they will turn the blue litmus to red. They will turn the color of blue litmus to red. The next one, they give H plus ions when they are mixed with aqueous solution, or then when they are mixed in aqueous solution they will produce H plus ions. So these are the properties of acids. First one, the sour in taste, then they will change blue to red litmus. Then they produce aqueous, in aqueous solution they will be releasing H plus ions, and they corrode metals. The acids will corrode metals because they are reactive towards the metals. Then here is an example of strong acids and weak acids. So strong acids includes it's HCl, sulfuric acid, means hydrochloric acid, sulfuric acid, acetic acid, oxalic acid and citric acids are weak acids. So these are the weak acids, and the hydrochloric acid and sulfuric acid are the strong acids. And here it is, what is this? This is lemon. So the lemon is having citric acid, which is a weak acid. So when blue litmus paper is kept on the lemon, what happens is, just look at the color of this blue litmus, it will be changing to red color. So litmus is a indicator which will be helping to identify the color of the, that means if a pH paper is kept on an acid, the blue color will be changing to red. So if you are keeping red litmus paper, there will be no change, but if you are keeping blue litmus paper, it will be changing to red. Then next concept, next we have to understand about concentrated acid and dilute acid. So what is concentrated acid? Those acid which will be having, that means in here the acid concentration will be high and water concentration will be very less. Okay, so this is about the concentrated acid. So this concentrated acid is mixed with water. So this concentrated this one, okay, so this concentrated acid is mixed with water. What happens? The concentration of acid compared will be less and the water will be more. So this is converted to dilute acid. So when an acid which is having less concentration of water means it is concentrated acid, and if you are adding water to it, if you are mixing water, then it will become dilute acid. In the dilute acid the concentration of water is more. Okay, so next one is bases. So first we studied about acid, now we are going to study the physical properties of the bases. So bases are bitter in taste, they will turn red litmus to blue, then they will produce hydroxide or OH minus ions in aqueous solutions. They are soapy in touch. Okay, so these are the physical properties of bases, and here is also an examples of strong bases and weak bases. Sodium hydroxide, potassium hydroxide and calcium hydroxide are the strong bases, while ammonium hydroxide is the weak bases. And one more term you want to study, alkali. So alkali, what is alkali? So alkali is a base which is fully dissolving in water. So if a base which is dissolving, which is soluble in water, we call that base as an alkali. Okay, the next one we want to indicators. So what is indicator? These are the substance which changes their color, smell in different types of substance. That means what is the need of indicators? So if you are given a substance, so here just look, here a substance X is given. So I am telling you to identify whether this X is acid, base or neutral. Then how will you identify? You will just look the taste, and if it is sour, then if you touch, then if it is soapy, like that you will observe. No, you cannot do for every chemicals, because chemicals are actually very dangerous. Some chemicals are very dangerous, so you cannot taste every chemical and tell. So for that there is indicators which will be if these indicators are mixed with the substance, then they will be either changing the color or a smell will be produced. So these are, by these criteria we can understand whether that is acid or base. So first category is natural indicators. Those indicators which is found in nature are called natural indicators. So litmus is a natural indicator. So in the acid, what is the color of litmus? It is red. Okay, so it is red. Then in the case of base, it is blue. Then in the case of turmeric, you know turmeric. Turmeric means haldi. In Hindi, it's haldi. Then what is the peculiarity of that? Have you ever touched the turmeric with soap? Then it will be changing to red color. So in the base, soap is a base. So in the base, it is red color, and in the acid, no color change. It is already in yellow color, so the same yellow will be there. Okay. So this is about the natural indicators. The next one is synthetic indicator. So we have two synthetic indicators to study here. So methyl orange and phenolphthalein. So these are chemically prepared. These are not natural. These are chemically prepared, and they will be showing two different colors in both acid and base. So methyl orange will gives red color. Methyl orange will gives red color in acid, and it will be giving yellow color in base. Okay. So methyl orange will be giving yellow color in base and red color in acid. So similarly, phenolphthalein will be giving colorless. Phenolphthalein will be giving colorless in acid, and in base it will give this color. In base it will be giving rose, not rose, it is pink. It is dark pink in color. So phenolphthalein in base it is pink in color, but in acid it is colorless. Okay, in acid it is colorless. This is the color. In acid it is colorless. In base it will be giving pink color. Then next one is olfactory indicators. So what is olfactory indicators? So already we studied natural indicator, then chemically prepared synthetic indicators. The next one is olfactory indicators. So these substances have different order in acid and bases. So if the smell of the substance is changing, if we are keeping in acid medium or alkali medium, so it's how we can look. So vanilla essence, what is the vanilla essence do? So the vanilla essence actually what does is, it will be increasing the smell in acid, and there is no change in the base. Okay, so there is an increase in the smell if we are keeping in acid, then there is no change in the smell if you are keeping in the base. Then next one is clove oil. So clove oil also similarly, it will be increasing smell in acid media, but it will be decreasing in the base media. Okay, so this is about the olfactory indicators. The next one is about the chemical properties of acid and bases. Okay, so we know the acid will be reacting with metal, that we already in the first slide we already discussed. So acid plus metal gives what? Acid plus metal gives salt and hydrogen. Base plus metal also will produce salt and hydrogen. So example is given. Instead of acid we are taking HCl. HCl plus zinc metal gives zinc chloride, plus hydrogen gas is evolved. It is hydrogen gas. Okay. Then similarly sodium hydroxide plus zinc metal gives sodium zincate. So it is a sodium zincate. Sodium zincate. CATE. Okay. So here also the hydrogen gas is released. Yeah, next one. So we discussed about the reaction with metals. Yeah, then this hydrogen gas which is released in both the cases of acid and bases, how we can test it is a hydrogen gas? So this hydrogen gas is released, can be tested by bringing burning candle near the gas bubbles, then it will be bursting with a pop sound. So if you are bringing the tube, the gas is evolved and it is kept in the water and the bubbles are coming out, and if you are keeping a candle, we can hear the pop-up sound. So we can indicate and confirm that this gas produced is hydrogen. Okay, so next one is the reaction of metal carbonates or metal hydrogen carbonate with acids and bases. So acid plus metal carbonate or acid plus metal hydrogen carbonate will be giving salt plus carbon dioxide plus hydrogen. Okay, so everything is common. So yeah, so it will be producing, salt will be produced, then carbon dioxide also will be released, then water also will be released. So here we want to note the important thing is that it is carbon dioxide. The carbon dioxide is evolved. Then the bases do not react with metal carbonates and metal hydrogen carbonates. Okay, so this carbon dioxide, how we can test this carbon dioxide? The carbon dioxide can be tested by passing it through the lime water. So if we are passing lime water with this carbon dioxide, then it will be turning to slaked lime. So it will be turning to milky in color. Okay, milky color. The calcium carbonate will be in milky color. Then again, if you are passing excess carbon dioxide, then what happens? This and this is already here itself. So plus additionally carbon dioxide, then new compound calcium hydrogen carbonate will be formed. So this compound will be again colorless. Okay, so again it will be, that means first initially it was lime water was colorless, then it will be turning milky, again carbon dioxide is passed, and again this milky will be turning to colorless. So we can confirm this is carbon dioxide gas. Okay, then next one is reaction of acids and bases with each other. So acid plus base always gives salt and water, that we know. So it is called as neutralization reaction. Here is one example. Instead of acid we are taking as HCl, then instead of base we are taking as sodium hydroxide, then sodium chloride salt is formed and water is also formed, means water is also produced. Then it is called as neutralization reaction. When an acid and base react to form water and salt, it is called neutralization reaction. Because why? H plus is there in the case of acid and OH minus is there in the case of base. So it will be forming 2 H plus plus OH minus gives H2O. Okay, then reaction of metallic oxide with acids. So acid plus metal oxides gives salt plus water. So here is given, that means here it is telling that these metal oxides are basic. It is basic. Metal oxides means basic. Okay, so instead of acid we can take HCl plus CaO produce what? CaCl2 plus salt is produced plus water is also there. Okay, so this is the result. That means acid plus metallic oxide produce salt, that is CaCl2 plus water. Then in the case of non-metallic oxide, what is non-metallic oxide? Here metallic oxide is basic. I told metallic oxide is basic. So non-metallic oxide will be acidic. So it will be acidic. So we can take like already here it is given. So it is non-metallic oxide, then base is then CaCO3 plus H2O. So salt is calcium carbonate. Okay, next one. So now we can just look the comparison. This much time we are discussing about the differences between acid and base. Now we can look what are things which is common in both bases or acid. So all the acids have H plus ions. Since it is having H plus ions only, now that only why we are calling it as an acid. Acid means it is having H plus ions, or we can define an acid when a substance we are dissolving in water, it will be producing H plus ions. So bases, similarly bases will be releasing OH minus ions, or they have OH minus ions. Then these H plus ions responsible for their acidic properties. So they acids have acidic property due to this H plus ions. Similarly bases have basic property due to this base OH minus ion, hydroxide ion. Then next one, when we are mixing acids and bases in water, actually what happens is, that means when we are mixing HCl in water, what will happen? Actually what happens is HCl will be splitting to H plus and Cl minus. But H plus cannot be surviving alone. So what it does is, this H plus will be combining with H2O and will be producing hydronium ion. H3O plus, it's called hydronium. So H3O plus is produced, then chlorine will be means it will be singular, means it will be in the solution as Cl minus only. So H plus ions cannot exist alone. That's why they are existing in the form of H3O plus or hydronium ions. So similarly the bases will not be they don't have like this, they will be like splitting. So when a sodium hydroxide, that means a base, is mixed with water, then it will be splitting to Na plus and OH minus. So that dissolve in water to produce OH minus ions or hydroxide ions. Yes. Then next important, this much time we are discussing about the indicators. So natural indicators, olfactory indicators and all we discuss. Now we are going to study about the universal indicator. So what is a universal indicator? It is a mixture of several indicators. It shows different colors in different concentration of hydronium ions or H plus ions in the form of solution. So with the help of this pH, we can exactly determine the pH. So this much time we can only understand it is acid or base. Okay, so but we cannot understand it is strong acid or it is weak acid, or like that we cannot identify. So with the help of this pH paper, we can identify it is what is the pH. So 7 is the neutral. So 7 is the neutral. From 8, 9, 10 and all, it is slightly, means weak base. Then from here it is high base or strong base. Similarly 7, 6, 5, like this 4, it is weak acid. Then 1, 2, 3, 4 and all, it is strong acid. Okay, so we can look the color and understand whether it is strong acid or weak acid, like that. Just look at this one, look at this diagram. So if it is telling about the concentration of H plus ions, if it is concentration of H plus ions is less, means the concentration of hydroxide ion will be more. So the sum of the concentration of H plus ions and OH minus ion will be constant. Okay, so just understand, it is a, by the presence of H plus ions only we can determine the color. So if the color, if we are determining, we can find the exact pH of the compound or substance which is given. Okay, next one. So what is the importance of this pH in our daily life? So what is pH? pH means it's a concentration of this H plus ion. So everything is having a particular concentration of this pH. So our body works between the pH range of 7 to 7.8. So our body also having a range of pH between 7 to 7.8. So if pH of rain less than 5.6, then we call that rain as acid rain. So it is harmful. So if a pH is decreasing below 5.6, then that rain is harmful for us and we call that rain as acid rain. Then our stomach will be producing HCl. Okay, so it is acid, so that it will be slightly 2 and all. The 2 decay starts when pH of mouth less than 5.5. So in our mouth, if the pH is decreasing less than 5.5, then it is danger for us, or means not danger actually, but our tooth will be decay, because the bacteria can survive at that temperature, that pH. So plant needs specific pH for the healthy growth. So some soil will be having a different pH, so many of the plants will be not be growing, so they need specific pH. Then self defense by animals. So here is a bee. So if a bee is stinging, means what is actually happening? The bee sting is having methanoic acid, which will be releasing by this bee, means, if bee is stinging, means it will be kept in our skin, so it is having methanoic acid. That's why we will feel irritation after a bee sting. Then next topic. So this much time we are discussing about acid. Base is also finished. Now we are going to study deeply about the salt. So salt means actually it is a compound which is produced from the reaction, neutralization reaction, that is a mixture of base and acid. So here we are going to study some of the application of this salt formation. So here we are going to first study about the formation of sodium hydroxide. Then next we will be studying the bleaching powder formation, then baking soda, washing soda, then plaster of Paris. So these are the applications. So these compounds are formed. These are the salt. So we'll be studying how the formation of these things in the next slides. So first understand acid plus base gives salt and water. So example is given. Sodium chloride is our common salt. Then calcium chloride. Calcium chloride CaCl2. Okay. So calcium chloride is another salt. Okay. Next we can go to study and the formation of sodium hydroxide. So sodium hydroxide, or it's called as caustic soda. So how is the formation of the sodium chloride? So it is caused when sodium chloride plus water in the presence of electricity. So electricity is needed here. So in the presence of electricity, it will be producing sodium hydroxide. Then chlorine gas is evolved and hydrogen gas is also evolved. That means when electricity passes through an aqueous solution of sodium chloride, it is decomposing to form sodium hydroxide. So this is how the sodium hydroxide is formed. It is a decomposition reaction in which the electricity is passed. Okay. So what are the uses of this sodium hydroxide? It is used to make soaps and detergent. Then it is also used in paper manufacturing. It is used in oil refining. Then PVC, that means polyvinyl chloride, it's a pipe and plastic related coating covers, etc. Then it is also used as pesticides. So these are the uses of this sodium hydroxide. These are the applications where this chemical reaction is used. So at this much 5-6 uses are there. Not only 5-6, many uses are there. So these are the main uses of this sodium hydroxide. Okay. Then next one is bleaching powder. So what is bleaching powder? Bleaching powder means CaOCl2. So how it is produced? So bleaching powder is produced by the action of chlorine on a dry slaked lime. So this is chlorine. So this is a dry slaked lime. So slaked lime means calcium hydroxide plus chlorine gives CaOCl2 plus H2O. So this is how the bleaching powder is produced. So what are the uses of this bleaching powder? Bleaching powder is helping for the bleaching of cotton and linen industries. In the cloth industries it will be helping. Then it is helping in the bleaching of wood pulp in paper industries. Then it is also helping as an oxidizing agent in chemical industries. Then it will be disinfecting or drinking water. So it is main point, it will be bleaching powder will be disinfecting drinking water, and it is oxidizing agent in chemical industries. So these are the uses of bleaching powder, and it is formed with the help of slaked lime plus chlorine gas. Okay. Then next one is baking soda. So what is baking soda? So how the formation of baking soda? Baking soda or sodium hydrogen carbonate, it can be formed with help of sodium chloride plus water plus carbon dioxide plus ammonia. So these are mixer, then ammonium chloride and baking soda is produced. Okay, so this is how the baking soda is produced. That means baking soda is produced by sodium chloride, water, carbon dioxide and ammonia. And what are the properties of this baking soda? So it is mild and it is non-corrosive base. It is non-corrosive base. Okay. So when it is heated, when this baking soda or sodium hydrogen carbonate is heated, what happens? It is producing sodium carbonate, water and carbon dioxide. So carbon dioxide is here is an important that I will tell. Then sodium carbonate is produced. So baking powder. Okay. So what are the uses of this baking powder? It's an ingredient antacid. What is an antacid? Antacid means if a person who is having acidity, then he will be taking antacid to reduce or to uh, kill that acid in present in that means it will be acting as a base, so it will be decreasing that acid effect. Okay, it will be nullifying that acid effect. So sodium carbonate is taken as an antacid. So it is this reaction is ongoing in this uh, that means baking soda. The baking soda is used as a fire extinguisher. Why? Because this baking soda is heated, and if it is put on fire, carbon dioxide will be released. So it will be carbon dioxide. What happens? The fire will be off. Okay. So this is the use of the baking soda. Then for making baking powder for making baking powder, we are using this sodium hydrogen carbonate or baking soda. Baking powder means baking soda plus tartaric acid. So baking soda is mixed with tartaric acid, then baking powder is produced. So what is the use of baking powder? Baking powder is used in breads and cakes. So that's why it is soft in nature, and it is spongy also. So this sponge is due to this carbon dioxide. So it is producing carbon dioxide gas. So it will be producing like so many in bread and all you have seen. So pores are there. Why? Because carbon dioxide gas is released. That's why it is appearing as like bulged air holes are present. Okay. Then next one is washing soda. So what is washing soda? It's a sodium carbonate 10H2 or sodium carbonate decahydrate. So recrystallization of sodium carbonate gives washing soda. Sodium carbonate plus 10 water gives washing soda. Okay, so what are the uses? It is used in the preparation of glass, soap and paper industries, then manufacture of a compound called borax. Then it is also used as a cleaning agent in houses. Then removing, it is used in removing hardness of water. That is washing soda is used for removing water hardness. Okay, hard water, to remove hard water it is used. Then last one, this is our last topic. So last topic is about plaster of Paris. So what is plaster of Paris? So here we want to study two compounds. One is gypsum and one is plaster of Paris. So these are irreversible process. That means when we are heating gypsum, the formula is CaSO4 dot 2H2O. When we are heating this compound, that is CaSO4 plus dot 2H2O at 100 degrees Celsius, it loses water molecules. This water will be losing. This 1.5 water will be losing and it becomes this one plaster of Paris, that is CaSO4 dot half H2O. Okay, so it is a white powder. On mixing it with water changes to gypsum, so it produces plaster of Paris, which is a white powder in nature. Then this white powder is again mixed with water. Then what happens is again the gypsum is produced, that is CaSO4 dot 2H2O. So what is the use of this CaSO4 dot half H2O, that is plaster of Paris white powder? Doctors use to support fractured bonds. So if your bonds are fractured, they will be using like mixing it water and putting in your bonds. So it will be after some time it will be hard and you cannot move. It will be gypsum if it is mixed with water. Then for making toys, decoration materials, etc., for making surface smooth. Okay, so these are the uses of plaster of Paris. So we discussed this much in this chapter. Okay, so first we discuss what is an acid and what is a base. Then what are the indicators, different types of indicators. Then the reaction of metal with acid and base. Then how we can study the hydrogen gas evolution. Then when metal carbonates or metal hydrogen carbonates are reacted with acid and bases, what are produced, then carbon dioxide and water is evolved. Then how we can test the evolution of this carbon dioxide, that also we'll discuss. Then salt formation, then a reaction with metal oxide, that means metal oxide is basic and non-metal oxide is acid. So acid plus base is salt, and base plus acid is also salt. So what do acids and bases have in common? H plus ions and OH minus ions, that also we discuss. Then hydronium ions, then OH hydroxide ions. About pH indicator, universal indicator is pH. It depends upon the H plus concentration. So then what are the use of this pH? Then what is salt? Acid plus gives salt, and these are the different types of salt. Sodium hydroxide, it's called caustic soda. Then bleaching powder, then baking soda, washing soda, plaster of paris. So uses of this sodium hydroxide, uses of bleaching powder, uses of baking soda, then what is washing soda, then uses of plaster of paris. So these are the things we have all, or means almost 99 percentage we completed in the chapter. So just look the about, means look and read about the chapter fully, read the textbook fully. If you have any doubts, you can ask me, don't feel any bad. Okay, thank you.